Hey yo, what is going on? It's your boy. So today we're going to be talking a bit more about electron excitation and the line spectrum of hydrogen. So before anything, let me draw something out. Okay. This is hydrogen, and I didn't draw a complete orbital diagram, but just take into consideration that every kind of curved line here is a shell. Hydrogen has one electron. And just because hydrogen only occupies one shell doesn't mean there aren't more. In fact, every atom has an infinity amount of shells. The reason we're capable of fitting all of those shells into one picture is because energy levels have two properties. First one is that they are converging. This means that every shell infinitely gets closer to one another further away from the nucleus. So shells converge at higher energy levels, which is what you can see happening. The gap from N1 to N2 is about 50% larger than the gap from N2 to N3. And from N3 to N4 is smaller than N2 to N3, and from N4 to N5 is smaller than N3 to N4. So we say that shells infinitely get closer to one another as we move further away from the nucleus. The second property about energy levels is that energy levels are concentric. This means that shells exist in between one another, or they exist within one another. Say, for example, I heated this hydrogen atom up. I fueled it with energy. When I fuel my atom with energy, we say that my electrons get excited. They have energy now. They start shaking in the place they are. Right now, we say that the electron is in ground state. It hasn't moved yet, and it's in the state it should be in. It's in the n=1 shell, the shell the electron should originally be in. But when the electron gets excited enough, when we pump enough energy into the atom, the electron gradually begins to transition from shell to shell, moving up energy levels. In this process, energy is being absorbed. When my atom loses that energy, right? When it's reached this newer, higher level, but the energy has begun to subside, my energy begins to slowly transition back into ground state. Energy, when the electron's going back to ground state, is being emitted. And characteristically, energy is being emitted in the form of a photon, which means when electrons transition from its excited state to ground state, energy is being emitted and a photon is created. Now, with hydrogen, the type of photon emitted is dependent on how much energy is being released. So there are a couple of key ideas when we're talking about photon emission. So recall the scope of electromagnetic radiation. We have UV. Some common electromagnetic radiation is from weakest or longest wavelength to shortest wavelength, and strongest is infrared. You have your visible light. Then you have ultraviolet. So ultraviolet has the shortest wavelength. Infrared has the longest wavelength. So the least energy. And then UV has the shortest wavelength and the most energy. So typically, if I told you I had if my electron transitioned after being excited from N2 to N equals 1, I have a couple examples. Say my photon transitioned from N equals 2 to N equals 1. Say another electron transitioned from N equals 3 to N equals 2. And I had another electron which transitioned from N equals 4 to N equals 3. What kind of photon would each transition emit? So N equals 2 to N equals 1 would release a lot more energy than the other two examples, because the gap between N equals 1 and N equals 2 is a lot bigger than the gap from N equals 2 to N equals 3 or N equals 3 to N equals 4. So N equals 2 to N equals 1 releases the most energy. So it would emit ultraviolet light. N equals 3 to N equals 2 would emit visible light. And because N equals 4 to N equals 3 isn't that big of a jump, right? Isn't that big of a gap, it would not emit that much energy. So it would emit infrared. So I hope that was a bit helpful in understanding a bit more about electron excitation and some properties of energy levels. If you have any questions, feel free to comment. And yeah.